Hi, welcome to my YouTube channel. Today I'm going to explain you about extract command. I think most of you guys face issue while simulating. You run the code for extract, but still you can't get the result. So today I will try to eliminate that issue from your simulation code. So starting with the videos, I'm going to present my next slide. Extract. So extract is a command in deck build. So deck build you can run the David, Athena, Atlas. So you can use the extract command in all of the threes. Okay. And then the purpose you know that like purpose is it helps you to get the more result from previous simulated log files like power, efficiency, subthreshold slope, and threshold voltage. You can get these things using a log file to Excel file, but that needs to do some extra efforts. Here, you don't need to do that much extra efforts. You can easily get the value, and you don't need to do some log file to CSV file and then do their manipulation. You can easily do it here. There's many more things here. You can use that for your simulations. So one more benefit is there that it's have a flexible syntax that allows you to construct specific extract command. So now going to next slide. So extract allows to user to construct a curve using separate x and y axis. So if you want to simulate some separate x and y axis, so like if you want to do something in x axis that is in y axis, you can do it here. And if you want to something in want to do some curve which is not in display command, like something is not available, like capacitance versus voltage or capacitance versus current is not there. So you can do it there. Like many more things that is not present there, you can do manipulated ones. Like if you are want to do power versus voltage that is not in display command, right? So you can easily do that here. Okay. And like there you can do easily multiplications, divisions, algebraic functions like square root, squaring, multiplication, derivative. So you can do it easily in the extract command. You can choose the voltage or current or any electrode, the capacitance or conductance in any axis. Like you want to change the axis for conductance, or you want to show results for some different one x and y axis one. So you can do it in a extract command. Now coming to the syntax one. So like if currently open log file you want to generate the data from extract, you can do it directly like log out of my file.log and the solve command, like whatever you are doing DC biasing and your wavelength change, like wavelength you are simulating for a particular wavelength or something, you can easily get the data from here like extract name and peak id max I dot drain. So here you can see that I dot and two curly, you can say not curly, you can say two commas in this there, and there's a drain. So that means that is access. So it's saying that current access, current I drain, it's taking data from drain current, okay, and that maximum value, and its name as a peak ID. So if you want to use peak ID anywhere in the simulations in the bottom one, bottom to that, you can use dollar $peak ID. You can easily use that also. Okay, now going to next slide. So one more thing, like to extract the same data from previously run simulations, like in the previous one I have run the same things, right? So there is another way, right? That is some you are not writing extract init in file, but if you want, if you do some other ways also, you can do it that way, this way also. Here one more benefit is that if it is not a previously open log file and it is some, you can say two, three simulation behind or one, two simulations behind log files. So you can also run that log file here also. Like how? You can just write the log file name and just add the command what you want, extract command. Like here I have done some mistake. I will tell you, like extract I have done mistakenly. That is extract. Okay. So you can correct those in your simulations. Now coming to the next slide. One more thing I want to discuss you, like most of the time you get the some pop-up uh, window is that you are your result is not there and your result not there. So what happens is sometimes that your code have some issues. So the code is not running properly. So the log file is not generated. then you can't get the extract in it, or maybe if you get, that is previous one. So you have to check. Okay, now this kind of error you may face, so you have to check how you can correct those. Okay, so you have to change in your coding, and like if your extract command is proper, then if coding is proper, and then you will easily get the things that extract run. Okay, but there is a like chances that if it is not running, you will get a previous calculated results, like previous calculated extract results. So you have to take care whether it is a previous calculated results or it's a new one. If it is not showing errors in a pop-up one. Okay, so take care of these things. Now coming to the some like beneficial commands for you guys, like transconductance. Like for transconduction, you can use the syntax or command. You can say extract name dydx, or you want to change it transconductance, you can change this as a transconductance also, but it is a universal one, not for transconductance only. So that's why I have mentioned dy dx. So like derivative v dot get I dot n, you know that di by dvgs it is, so you will get the transconductance from here. Okay, but the access may be different. For like sometimes you need second order derivative, third order derivative, fourth order derivative, fifth order derivative. So you can use similar command like the above one, but there is a change that there is a 2 for second order, 3 for third order, fourth for fourth order, fifth for fifth order. So and derivative you can use and something like that. So now coming to the syntax. So like there is a many manipulation you can do in the access. Access is like as I told you, right? I dot drain is access data. V dot get is access data. And the first one is X and the second one is Y. So this one is X and this one is a Y. So for I have done the manipulation drain current data, that is absolute. Absolute is, you know, that we need only magnitude, not need any positive negative. So you can use absolute I dot drain, absolute v dot get. Similarly for log file with e base and log 10 for 10 as a base. If you want to use square root, you can use that. A10, you want to use A10 also, you can use that. And there is many more functions here like that in the Silvaco extract command. So you can easily get extract curve and this data, like something you can see here. Now going to some more manipulations, curve manipulations. You can see that you can calculate the mean curve, max curve. AV is for average, mean slope, minimum slope of that, maximum slope of that, slope, x-intercept, y-intercept. You can get these kind of things in the simulations and many more. I will show you one more. Here is if you want to some area from curve where x mean is x1 and x dot max is x2. So if you want particular area, you can as also get from here. Also one more thing, x dot value from curve where y dot value is k. Like if you want to like you know that y value as a k and you want to get the x value, you can easily get that. If you know the x value and you want to get the y value for that, you can easily get that. That you know that you need to see that results, like sometimes you want to see at gate voltage 0 what is the drain current, or when the gate voltage is like, or you can say in the solar cells you have seen that GSC when the voltage is 0, anode voltage 0, and for like VOC you need cathode current as a 0, so you can get that data. So for that you need these kind of commands. And one more example is there, like how you can use the above manipulation and this one manipulation. So you can see that this is a for us, you can say some VT in which you are like x-intercept, max slope, curve, like curve, absolute from like V dot get and absolute I dot drain. So what is that? Absolute of I dot drain. So you will get the absolute I drain current, and that is V dot get the two axes x and y that you are plotting. Okay, and that curve means that you are plotting that. Okay, and from that you are calculating the max slope, and that max slope give you the intercept. So this way you can say series of command and that will give the VT. It's some voltage, like threshold type voltage. It is not like a threshold voltage but is in MOSFET, it's some different one. So x intercept, max slope, curve. So you can see that you can go in to out. Okay, not out to in, most try to go in to out. So you can see that it's between the curve of v dot get and absolute of I dot drain, and that curve is utilized to get the max slope, and that max slope is utilized to get the x intercept, and that data we need. Okay, it will give that data. So okay, you got it. Now comes to next one, like this one is more easy, like you can easily understand, like I don't need to dictate, but I will dictate for for continuing this video. But like see, I dot drain v dot get, x is I dot drain, v dot get is y. Okay, and that need to be made in a curve. Okay, we have made the curve, and then you need to some minimum value from that curve, you get the minimum value. If you need some maximum value from this one, like it is C for capacitance, right? C for capacitance between base and collector, between base and collector, and this is a base, so x and y, this is x comma is separating the x and y. Curve is the curve which you are drawing, and that you need to be a maximum value. Okay, similarly, like as tell you, right, for C4 capacitance, and yeah, you got to know like capacitance is between the two uh, base and collector, so that is base and collector, you have to write that. Okay, so max operator with access intercept, like most of the times you need intercept, like so like this is some random like not a random one, you can utilize in your one, like beta, for it is for beta, you want to some draw beta, which what is the maximum beta for some particular value, you can get it from here. So see, like it is a curve between IC and IC by IB, or you can say beta, you know that in a BGT. So you are getting from the curve I collector and I collector divided by I base. So you can see that this is division manipulation, and you want some maximum value of you want to get some maximum value of uh, x value where the beta is maximum. So you want to get the x value of IC where the beta is maximum. You can understand the max of I collector I base, that means max of beta or in the y-axis, and that you want what IC give you the max beta. Okay. Similarly, what uh, what capacitance between CG and D you will get, minimum capacitance you will get with the time and C gate drain curve. Okay, you want to know some like time at which you are getting minimum CGD. Okay, and this is X and Y. Oh, you got to know like X and Y. It is X always, and this is Y. Okay, now coming to next one. So y accepts access interception of a line created by mean slope operator. So abstract name y for ISPD, y intercept mean slope curve and I substrate and V drain. So as I told you, go from here to here. Okay, so you are making a curve between I substrate and V drain. I is axis and x axis, and V dot drain is a y axis. You are making a curve. Okay, so curve is there, and then you want to some minimum slope in that. So minimum slope of you want of in the curve of I substrate and V drain. You get the minimum slope, like you know that minimum slope is di substrate, no sorry, dv drain upon my di substrate. Okay, and that you got like you're differentiating that, and you get that the minimum slope. Okay, and that you are using as a calculate the y-intercept, that where that line intercept the y-axis, so you can get it here. Okay, I'm trying to tell you in the sense of mathematical equations, because it is something mathematical equations which is written in a statement forms, so try to correlate with that. Okay, so you got it right, curve, and that you want to minimum slope, and then you want to y-intercept. Similarly, one more thing is you will find that value dot OK, occurrence. It's occurrence. This is a value val dot occurrence. So most of the time you will find in your like examples one, right? You have not used till now. Maybe many of you guys used, but if somebody is not using, like you will get many of the example like val dot occurrence. Okay, value dot occurrence number of times. What is the number of times? Like what happens is, like if you are making a curve, right? So there are chances that the same points, like as I written that x value as a 2.3. So maybe there is a chance that the 2.3 x value is coming two times. Like there is a curve, some curve, right, in which x dot value is a 2.3. So you get a 2y value. So tools will all, that always confuse, right? Which y value you need. So it means that the first occurrence is the like minimum one and that maximum one. So it take as like, so you need a second occurrence. So if there's a some y value is there already, so you need some other occurrence. Like first time it occurs, then second times you need. If you need, like if it occurs three times, so you write three, and you need third one, so you can get third one. So like if you are writing one, so you get first occurrence, and if you get write second, then you get second occurrence, and if you need third occurrence, the third occurrence. So either you can use this one, or you can use, if you don't use that, that will give you a default one, like first occurrence only. If you use second and third one, so you will get a like more occurrence. Okay, so you can understand this one also, right? Like absolute I collector, V base, it's an x-axis, it's an y-axis. That there you need to be absolute one. Like if it is negative, you get a positive, and that you need to make a curve, and that from that you need to multiplications that well dot occurrence as a 2. So then you need a second occurrence of 2.3, and you want their y value. Okay. Now coming to the our last part or last slide here. Okay, so this is a subthreshold slope. Okay, so let's understand the, oh sorry, this is a subthreshold slope and threshold voltage and a leakage current. So starting with the leakage current, it's a simple one. So it, you can easily understand that you need a drain uh, current access, their absolute value and their maximum one. So you get the maximum value. So that is the like leakage current. If it is some, this is code for some leakage current, so you can easily get it some leak current. Okay. um, it have a some several purpose, right? It doesn't mean that it's only leak. It may be for other purpose also, but it's particularly for leak one in the like in the Silvaco command line, or you can say whatever it gives you like GUI type mode. There is a little leak. You can use many ways. Like it is not that leak. You can use some other one, max I drain. You can use like this also, right? It is not the issue. What name is in your control. You can name it anyway. Syntax is also in your control, but you have to be take care of some format, right? So you got it right for the max drain. Okay, and then coming to subsurface slope. So what you know that subsurface slope is easily you can get it from like making the curve between V gate and the uh, I drain, right? That is in a log 10 format. Okay, you get the curve, right, with the both as a offset value, and you are making the maximum slope of that. You get the maximum slope, and that slope you like easily get from slope command, right? And that slope is utilized to 1 upon something, and that is you will get the subthreshold swing. You can say swing and slope. I think slope is not there, it's a swing, because 1 upon something is swing, I guess. Yeah, so it's a swing. So you can easily get that here with this multiplication. You can easily understand, right? Now I have already explained you multiple times these things. For now, for VT, I will explain for VT because there is some more modification here. See that for the first part, you can easily understand, right? Like it's between the V gate and I drain. So it's x-axis, it's a y-axis. So you get the curve, and that you need to be maximum slope, and from that you need a x-intercept. So you make an intercept on a x-axis, and you get the value, right? And that value you are subtracting from average of V drain and divide by 2. Okay, like average AV is average, so V drain voltage and it's divide and it's absolute, you are dividing by 2, and that you are subtracting with each other. Okay, and that you get the threshold voltage. Okay, so this is the way you can easily formulate in your pen or paper, and you will get that, oh, it is mean the same. There's many where in which they are using some different convention, like they are using y value as a -7 for calculating the threshold voltage. There's many ways. I'm not saying that my way is always this one, like you can use only this one. There's a many way to calculate the same things, right? So you prefer whatever you think it is easy for you, right? So that is all, and I will, if you need some help in extract command, you can message me in my email, WhatsApp, or you can say in my comment box. Anywhere you can message me and I will tell you what you can do for some particular one. Okay. Thank you.